Hello everybody, this is Rashid Abu Dhabi. I'm professor at Khalifa University and I'm the director of 3D Printing Center at Khalifa University. Today I'm going to talk about a very hot topic in the manufacturing industry. The title of my topic is 3D Printing and Additive Manufacturing at Forefront of Fourth Industrial Revolution. In fact, additive manufacturing now is a global disruptive technology which transforms many industries due to increased creativity in product design, easier production, reduced cost, and expedited on-demand manufacturing. Several UAE industries and governmental sectors started employing AM due to Dubai's strategy in 2016 in making it the world's 3D printing hub. And as I mentioned, AM is at the forefront of Industry 4.0, besides artificial intelligence, Internet of Things, robotics, and so on. AM market, in fact, reached 17 billion by 2020, from 4 billion in 2018. So we can see that there is a significant increase in the revenues coming from additive manufacturing. And in fact, there is an exponential growth these days in 3D printing. UAE additive manufacturing strategy, as I mentioned, in 2016, Sheikh Mohammed bin Rashid announced the strategy in making Dubai a hub for additive manufacturing, mainly focusing on construction. And last July this year, His Highness Sheikh Mohammed bin Rashid Al Maktoum announced the printing strategy Aliens. And he mentioned, and I'm quoting here, our goal is to accelerate the adoption and use of this emerging technology to support all governmental, economic, health, and scientific sectors in Dubai and the world. Through the Aliens and in cooperation with 3D printing companies, we will enhance our industrial capabilities, secure our basic needs, and create new production lines based on the employment of future technology. So that indicates really the significant interest of UAE in manufacturing, in additive manufacturing. In fact, recently there has been the news of a new ministry that focusing on manufacturing and innovative technologies that is led by His Excellency Dr. Sultan Al-Jaber, who is the CEO of ADNOC as well. Now, what does additive manufacturing? And commonly it is referred to as a 3D printing. The industry is really know it as a 3D printing, but these days they commonly refer to it as additive manufacturing. So it's one of the new manufacturing techniques. 3D printing used to be called, in fact, rapid prototyping. People, they used to use it for making models in order to test their hypothesis or test their idea. Sometimes they used to call it solid free form. And it's a process of joining materials to make objects from a 3D model data. And it's a layer by layer process. So basically you build one layer and then you bring the other layer on the top of it and the other layer until you form the whole subject, which was first described in 1986 by Charles Hull. In fact, Charles Hull filed a patent in 1986 describing the process, and we can see here a schematic from the patent itself showing the subject. And you can see that here this is the laser source that basically is solidifying a layer per layer. And what we see here that it is a resin through the laser will be solidified. In fact, before that, before 1986, there has many ideas about really manufacturing techniques that are similar to 3D printing or additive manufacturing. In fact, a gentleman in 1979 from Las Vegas used to go to work and he's passing through the Las Vegas desert and seeing the sun shining over the sand of the desert. And he thought about how we can create structures through really solidifying the sand particles. And in fact, he filed a patent at that time for this process describing, which is we know right now, in fact, is the laser powder bed fusion 3D printing method, where you can see here the powder, which resembles the sand particles here, and you can see the laser source, which kind of resembles the sun shining on the sand. And that laser is basically melting the powder, and through a cooling process, which is very fast, it solidifies the material, and then you can see another layer comes in. The process is repeated again and again until you form a complete structure. In fact, that gentleman, from Las Vegas, he went away from 3D printing, but his patent later on adapted by UT Austin, and they formed a company based on this patent. The patent that filed by Charles Hull in 1986, in fact, as a result, one of the biggest companies in additive manufacturing called the 3D Systems is nowadays a leader in 3D printing. Here I can show some of the examples of additive manufacturing techniques. One of the most famous and widely used technique is what we refer to as laser powder bed fusion technique. So basically you can see here a laser source, as I explained earlier, melting a powder layer. In this case, this is stainless steel powder is melted. So basically the temperature that comes from the laser exceeds the melting temperature of the powder, melted in the form by layer, and then there is another layer comes after that it's melted again, and that layer is basically has a certain thickness that is slightly bigger than the particle size of the powder. In fact, this process is a little bit slow, and that's one of the disadvantages of additive manufacturing, and this is why it is mainly used for niche products or high value products these days. Another technique which is used in construction industry, it's the material extrusion in construction. We can see here that there is the cement that is being diffused through a nozzle, and the cement has a certain fluidity that allows it to solidify immediately upon coming out of the nozzle. And this is a technique where buildings these days being made, and UAE in fact is one of the leaders in this additive manufacturing technique and its employment in making buildings, and that will be expanding more and more in the near future. Another additive manufacturing technique, which is one of the most widely used and the first used kind of 3D printing technique, is the fused deposition modeling, or what we refer to as FDM. Basically, you have a filament that is made of a plastic that passes through a nozzle, and that nozzle heats, or the head of the nozzle heats kind of the plastic filament and melt it, and then diffuse it in a layer based on the object that you want really to print. It forms it layer by layer in a relatively faster manner than other additive manufacturing techniques. And this technique is being mostly used to print plastics or polymer structures. These days also it has been used for making metallic components. In fact, a company that is right now worth more than $2 billion, being established in 2015, called Desktop Metal, use the same technique that used for FDM for printing plastic to print metals. Another technique which is also very good in making very detailed structures with very high resolution is what they refer to as stereolithography, which is based on using of resins. And that resin basically is solidified through using a Blu-ray laser, similar to the laser used in Blu-ray CDs. It's a low power laser, and the nice thing about this technique is relatively faster than any other techniques, and also the advantage of this technique is allowing you to print with very high resolution. Here you can see that the Eiffel Tower, being kind of printed. Of course, this is not real time. This is accelerated video. Relatively, to print that Eiffel Tower, it will take about 3 to 5 hours, depends on the resolution. Another technique is also being developed is binder jetting. Also, this is a technique based on using a powder, which is mainly used by architecture engineering for printing models or architectural models out of gypsum. This is a technique that is not mainly used for end user products as compared to the other techniques. Another technique which is called photopolymerization polyjet. You can see here again there is a resin that is deposited layer per layer, and then there is a UV light that cures that resin and solidify it to make the structure. So these are some of the really most famous additive manufacturing techniques that have been established. There is, as I mentioned earlier, booming in 3D printing, and there are new techniques that are really coming up almost from time to time to kind of address some of the challenges that facing the additive manufacturing industry, which I will highlight later on in my slides. Now, just here, this is I'm showing a comparison between traditional manufacturing technique and additive manufacturing. And as I mentioned, additive manufacturing typically referred to by the industry as a 3D printing. And many people there know it as a 3D printing, but the industry right now is moving into naming it as additive manufacturing to show that basically this technique can be used for end user products. You can print it, you can print a structure that can be used as a structural component in a functional system. So it is kind of going beyond rapid prototyping and doing modeling. You can see for subtractive manufacturing, basically that there's a lot of waste. Basically it's a process where you start with a bulk material and using a certain technique where you remove the material to form the object here. Let's say this is a sphere, and you see that there's a lot of waste because of this traditional manufacturing technique. As compared to additive manufacturing, the material loss is very minimal because you really use the material in a layer per layer fashion, and just through the post-processing process, you might lose some of the material that you have used. So this is a big advantage in additive manufacturing. And also another big advantage, which we were going to highlight later, is the ability to fabricate very complicated structures and components that you couldn't really fabricate before. Now, the steps of the AML process, in fact, starts from the design. You design the component through any of the CAD softwares like 3D SolidWorks or Autodesk or Materialize software. Any of these really CAD softwares, you design the component. And that's really the nice thing about really additive manufacturing is allow you to dream big and allow you to design structures with complexity without the limitation in the ability to fabricate that structure or not. And that's really very big advantage of additive manufacturing. Then you create out of the CAD file something called STL file, stands for stereolithography. And that STL file is sent to the printer in order to start the process of printing. Before you start the printing, of course, you need to specify which is the material to be used for the part, whether it is a plastic, whether it is a composite, or it's a metal. Also, the other process is establish build parameters. So based on the complexity of the structure, you select the building or printing parameters in order to get a very successful printing. Then you control the AM build the process to achieve the desired parts dimension, structure, and performance properties. Once you print the component, you might do some post-processing steps. For example, heat treatment in order to relieve residual stresses through the printing process, or to remove some of the material that is stuck on the surfaces of the component. Maybe you will paint the component to make it look nicer. You do final testing in order to certify the component in case if you want to use it in a certain application. The other final step that you need to do is to maintain and repair the machine, replace certain parts of the 3D printer. In this slide, I can show you kind of a comparison between injection molding versus additive manufacturing. I mean, injection molding is typically known to be used for mass production of components. For example, if I want to print a bottle of water, I'm not going to use additive manufacturing for that, because injection molding, I mean, you can literally fabricate thousands and thousands in a matter of very short time as compared to additive manufacturing, because additive manufacturing is done layer per layer, so it's a slow process. So typically it's used for small volume, not large volume. And you can see in this curve here, the unit cost on the y-axis versus the volume, how many components you want to fabricate or you need to manufacture. And you see here the blue line is the injection molding. So the cost, if the volume is very low, then the cost becomes really very high as compared to 3D printing. 3D printing costs, we show it here, kind of an idealized cost as a fixed cost. In fact, it's not ideally, I mean practically. But it's a fair idealization of the printing cost these days. And you can see that these two curves overlap or cross a certain point. And this point, in fact, changes every year. It's shifting, in fact, to the right every year. And typically, these days, it's on the range of about 1,000 components. So if you want really to fabricate 1,000 components, or more, then the choice is injection molding or subtractive, for example, techniques, or any other traditional manufacturing techniques. But if it's less than 1,000, then 3D printing cost, in this case, will be less, where the injection molding cost will be much, much higher. So it depends really on the number of components, the size of the component that you want to fabricate. You can choose whether to go for additive manufacturing or other traditional technique. Another very interesting curve here shown is the unit cost versus the complexity. Now, the more complicated the component, you can see that the traditional manufacturing techniques, the cost becomes really very high and goes exponential as the complexity increases. Whereas for additive manufacturing, I mean, there is no limit on the complexity of the structure. Whatever complexity you have, you can fabricate the structure, because the process is simply a layer per layer process. So you can see here that kind of the falling in costs of additive manufacturing from 2014 to 2020. So basically, it's reducing the cost more and more, and we expect that this to be enhanced and the cost to be reduced more and more with more developments in the coming few years. Now, the benefits of AM, basically there are several benefits of AM that I will name few of those. One of them is reduced use of material, reduced waste, and that's an example we show concerning subtractive fabrication and additive manufacturing. You can see here a component that is basically being made through CNC machining, and that's really the component, which is a bracket for aerospace applications. And you see the amount of waste that is being taken because of the fabrication of this component. And you see that the complexity is not that high as compared to the complexity of the same component that is fabricated through 3D printing. And in fact, because of the advantage of the ability to fabricate very complicated components, basically you can redesign the component in order to reduce its weight, increase its strength, and not affecting its functionality as compared to the part that is fabricated through traditional technique. And you see here that just very few waste that is left through additive manufacturing, which is typically used as a support material during the printing process of this component. So that's really a huge advantage for additive manufacturing in reducing waste. Of course, there is the advantage of reduced time to design. So basically, in the design cycle, you can really design a component within a week, be able to verify your design, whereas in other techniques, it may take about 6 months, and it may really cost a significant amount of money in order to verify a certain design. And then if the design doesn't work, you have to start really the design process again. Where in additive manufacturing, really the time cycle for the verifying the design is really short and quick. The other aspect to produce functional parts, that's where we said about the complexity of the structure that can be fabricated through additive manufacturing without really big limitation as compared to traditional techniques. So basically that adds a huge value. Shortening supply chain by allowing parts to be manufactured on site rather than at a distant supplier. So basically, if you have a CAD file of the component that you want to print, instead of really ordering it, and it takes a lot of time for shipping and then storing it, which really costs a lot of money, you can just, based on the CAD file that you have and the printer that you have, you can print on demand. Whenever you have the component and you need more of that component, you can print it on demand. So that's really kind of a game changer. Ability to produce complex parts, as I mentioned. So there's no limitation, the complexity. This is where it allows you to dream big and redesign certain components with enhanced functionality. Use of alternative materials with better performance characteristics. That's I will highlight it later on, how the characteristics of materials enhanced through additive manufacturing. Ability to create highly customized structures. Building a human capacity in 3D printing, manufacturing is a revolution in industry. So a lot of students, in fact, these days are interested in entering the field of additive manufacturing because the demand for people who have the expertise in additive manufacturing is increasing really exponentially with time, especially these days here in UAE. So with AM, seriously, you need to dream big. And all the time we say the sky is the limit with additive manufacturing. So the process starts with the design. And since there is no limitation in the complexity of the structure that you can design, then you can really design your component in a way to be more functional, more cost effective, and to perform in a much better way. And you can see some of these examples where this is a helmet for the bicycle, where it is really being designed in a way that very lightweight and enhances the aerodynamics, as well as enhances the comfort of the bike rider. Here you can see some of the examples of shoe with a very complicated structure that it's not possible to make these with traditional techniques. UAVs, unmanned air vehicles that are 3D printed, 80% 3D printed, which has been demonstrated recently. Some of the examples of industrial applications of additive manufacturing. In fact, the leaders in additive manufacturing have been so far aerospace. And the reason for that, it's because it's a niche industry. The cost there is not really of a big issue as compared to other industries. This is why they, willing to invest money for the sake of enhancing the performance, the safety of the airplane. You can see some of the components. This is a fuel nozzle that has been really fabricated by GE, and it was really game changer in 2015 because they used to fabricate this out of 36 components, but with additive manufacturing, you really fabricate it in one shot without any components. So that reduces the time. In fact, they redesigned this fuel nozzle to enhance the performance. You can see applications in medical, specifically in the dental industry, additive manufacturing, which is kind of really used for customized kind of implants for the human body, or here for the dental. Other applications also for space, looking into additive manufacturing, specifically for enhancing the performance, lightweightness. You can see here, this is a very successful example that is done by Etihad Airways, and we helped as Khalifa University in giving the needed expertise for Etihad Airways to achieve this great milestone, which is, in fact, they printed the shroud here, or the video monitor. So we reverse engineer it. We print it to be exactly the same as the one fabricated by traditional techniques. It has been certified within 6 months. So it was a very successful story. And Etihad Airways right now, they have, in fact, a strategy in order to print about 60% of the cabinet components of aircrafts using 3D printing by 2026. So this is a very ambitious plan by Etihad Airways. Also food. I mean, you can use additive manufacturing to customize the food, the taste, the texture when you put it in your mouth. So they use it, for example, here to print steak that really has a texture that is maybe better than normal steak. In the oil and gas industry, also they're looking into printing spare parts. In the automotive industry, they have been really the biggest users also of additive manufacturing for lightweightness and enhanced performance. In the construction industry, in fact, Dubai and UAE in general is these days is a leader in additive manufacturing or 3D printing in building and construction. And as I mentioned earlier, Dubai plans to have 25% of all buildings built with 3D printing by 2030. So this is one of the objectives of making Dubai and UAE a hub of additive manufacturing. We can see here the world's first 3D printed office in Dubai. And just last year, you can see here, this is a 2-story building, which is the Dubai largest 3D printed structure in the world. It's 9.5 meters tall with total area of 640 square meter, which has been fabricated through the additive manufacturing. And we can see the really potential of the additive manufacturing, the construction industry in reducing the time for construction. We can see a lot of areas where they are missing houses and areas where there's wars and refugees that basically they need homes. Imagine how 3D printing can be used to fabricate or to construct structures within a matter of a day. So that's definitely is a game changer. Opportunities available through AM, as I mentioned, complex parts, especially complex spare parts. So imagine that you have your inventory of components, and you can reverse engineer your component, you scan it, you convert it to the CAD file, and then you can print it. A lot of components these days in many companies, in nuclear industry, in oil and gas industry, in the aerospace industry, certain components cannot be fabricated anymore. I mean, the supply chain is closed. So basically, if you have the component and an old component, you can reverse engineer it, create the CAD file, and print it. The spare parts can be fabricated in one shot. As we said, material saving. It can be for mass production, less post-processing. Of course, this is an example here. I show the reverse engineering process of a component that we have in collaboration with Abu Dhabi Police. Basically, in an example where if you have a hit run, so you have an accident, somebody hit you, and then run away, you couldn't really catch the license number, and you reported the accident. Basically, you can see here, this is, for example, component of the rim. Some of the debris that are left in the accident scene can be reverse engineered, printed, sent to the service stations in order to check. Once the car comes to these service stations for repair, basically they can know exactly this is the size and this is the shape of the component that has been left in the accident scene, and basically they could be able to catch that person who made the accident. One of the also advantages of additive manufacturing is that additive manufacturing or 3D printing makes stronger parts. So AM has been used to fabricate a common stainless steel, which imparts a unique microstructure, making it stronger, more ductile than the production with conventional methods. You can see the unique kind of microstructure because of 3D printing. This is for stainless steel. You can see the microstructure being very complicated. There's a lot of what we call dislocations, and these dislocations are responsible for strengthening, making the structure stronger. You can see here, for example, what we call the strength versus the elongation, how much you stretch the component, and these curves showing the component made of stainless steel tested where it has a much higher strength, a much higher ductility, or what we call strain to failure or elongation until failure, as compared to conventional techniques. So that's a huge value. You are making the same component within the same material, but with a different fabrication technique, you end up with a much stronger component. And in fact, this is something that is of a significant importance for the automotive industry. And they have been for a long time looking for a fabrication technique or a material that has a balance between strength and ductility, or what we call elongation, until failure or fracture happens. So you can see here that this is where in the banana shape, they refer it as the banana shape, showing the strength, showing the elongation versus the strength, where typically the automotive industry, they need materials in this area, which has been achieved through additive manufacturing. Another big thing that is really need to be developed in additive manufacturing, especially because it is still in the development stage, is materials. So there are a limited number of materials that are available for 3D printing or additive manufacturing as compared to conventional techniques. For conventional techniques, in fact, there are millions. Of material availability as compared to 3D printing. 3D printing, there are thousands. So you can, really count kind of the materials that are available for 3D printing. So there is a need for development of new materials. In fact, metal powder is the most needed and used in additive manufacturing. Metallic additive manufacturing, to be able to print metallic components, this is something is becoming really very hot these days, and a lot of companies looking at the 3D printing with metals. So you can see here materials that are made in the form of powder, materials that are made in the form of filaments or pellets, as Borouge here in UAE doing something like this, or materials in the form of ink or resin, or even composites in terms of fibers and matrices. So these type of materials are being developed for additive manufacturing. The challenges of additive manufacturing, one, guidelines for selecting additives versus subtractive. So how do you choose that I want to make my component through additive manufacturing with 3D printing or through traditional techniques. So that needs to be set of guidelines. These set of guidelines are being developed but are not yet fully developed. Standards for using recycle and reuse of materials. So basically in the metallic 3D printing, you're using powder and you need to recycle the use of the powder to use it again. So there should be some standards. Standard for environmental conditions effects on the AM material, heat treatments and procedures needed to reduce anisotropy, so changing the properties in different directions. Guidelines are needed for post-processing. Standards needs to obtain minimum properties, qualification, certification standards by parts. So these all needed. Some of these really challenges are being addressed by the American Society of Testing Materials Additive Manufacturing Committee, which is established in 2009. And by now they have about 900 members. We are going to be UAE a member very soon. And the standards that have been developed, more than 25 standards, basically all of these standards focusing on the employment of additive manufacturing and how to certify and qualify an additive component, an additive fabricated component. Here at Khalifa University, in fact, we were one of the leaders in UAE in additive manufacturing, in fact, starting from 2013, where we have reached to several industries in UAE in order to make them aware of the importance of this new additive manufacturing technique. And so established in 2019 in July, ADAM Center. ADAM stands for Advanced Digital and Additive Manufacturing Center, and it serves as a state-of-the-art research and development and educational facility in the area of AM, and will be a platform to provide services to industries across the UAE. And in fact, it will be also used as a platform for capacity building, for educating students, for educating industry leaders about the importance of additive manufacturing. We have more than 40 people right now, with faculty, students, postdocs working within the center. And their main research partners is Strata, is a big player with us. New York University, Abu Dhabi, close collaborator with us, Etihad Airways, and the Aerospace Research and Innovation Center. The themes of the Additive Manufacturing Center, in fact, spans through the whole process of 3D printing, starting from the design process of the component, then the materials that needs to be used for printing the component, and then how to make the component lighter and more functional, printing, looking at the properties of that component, and looking at even the certification, qualification of the component. And the theme 5, as I mentioned, we are focusing on education, making workshops for students and for the industry. Some of the Khalifa University industrial additive manufacturing capabilities, in fact, there are many printers out there. Mostly they are desktop printers. They're small printers that being really used to fabricate components. The prices ranges, in fact, from $100 up to $1 million. So we're talking about here, this is some of the plastic 3D printers that can be fabricating components at the industrial level. This is can make two materials, can print two materials at the same time, soft and hard material. This is the big graph FDM, large volume. Can you print a large volume about 1 meter by 1 meter by 1 meter cubic structure? Another system that can be used, in fact, for making very high resolution components. It's a multi-jet technique. This is another based on the filaments of fused deposition modeling. This is a technique also based on gypsum that used by architecture or architectural engineering in order to make models for buildings. This is a metallic, a state-of-the-art, in fact, metallic printer, which is one of a kind here in the Middle East. It can print large component out of various types of metals, out of stainless steel, inconel, maraging steel, aluminum, and so on. And we have also the capability to print with ceramics, which is very important for the harsh environments here in UAE. Lastly, I would just highlight some of the activities that we have done at Khalifa University related to additive manufacturing. In fact, we filed several patents. I mean, because of 3D printing and the ability to fabricate very complicated components and functional components, we been engaged in making what we call metamaterials and metastructures, which are materials or structures that are driven by topology rather than chemistry. So this is kind of a new concept of making materials and functional components. So we applied really these type of materials to making membranes, making spacers for desalination, water treatment, or wastewater treatment, static mixers, which is used by the water industry and the chemical industry, mixing different fluids, catalytic converters that are made of ceramics, that has a very enhanced performance, mainly used by the oil and gas industry and the automotive industry, heat exchangers in order to enhance the performance and make really these very important components for many industries as compact and with higher performance. Batteries, three-dimensional batteries, that's another thing that you can print a three-dimensional battery for enhanced energy capacity and power. Heat sinks for dissipating heat, which is very important. I can see my laptop, in fact, right now is heating up, closing to finish my presentation, and there's a fan is running. And really with additive manufacturing, you can use it in order to make the dissipation of heat in a much more efficient. With that, thank you very much, and I'm welcome any questions. So I'm looking for some of the questions that I have received. The first question is, do you believe that 3D printing has a future in UAE? Will the country depend on it? I mean, as I mentioned, that UAE in fact has a very big strategy and ambition strategy for adapting additive manufacturing and the 3D printing in many industries. In fact, many industries right now in UAE, they are interested in employment of additive manufacturing. I believe that 3D printing has a future in the economy. It's not just UAE, in all countries around the world. And there are many countries that have been really very active in additive manufacturing as compared to many other countries in the Middle East. For sure, UAE is one of the leading countries in adapting additive manufacturing. And we showed some of the examples in construction, and where large functional buildings that being really built based on 3D printing in a very short time. In fact, recently DEWA, Dubai Authority for Water and Electricity, they built a research facility using 3D printing, and it's going to be incubated very soon. Will the country depend on it? I mean, I wouldn't say that. I mean, a country will hugely depend on it. There should be diversification in the manufacturing techniques. Additive manufacturing, in my opinion, will never replace some of the traditional techniques of fabrication, like injection molding. As I mentioned before, if I have this kind of a bottle of water that I really need to fabricate, I wouldn't think about additive manufacturing, 3D printing to use for printing or making that component. I would be thinking about injection molding, because you can really make thousands and thousands of these in a very short term, and what a huge cost reduction as compared to additive manufacturing. Additive manufacturing at the moment is really being used for small volume, for niche components, and we have really niche industries here, like the aerospace industry is growing here in UAE. So additive manufacturing is really ideal for such of these industries. Another question says, as you said that the FDM is the best AM technique, well, what's the disadvantages? This is a very good question. In fact, FDM, I wouldn't say that it is one of the best AM techniques. I would say it is one of the most popular additive manufacturing techniques. There are other techniques like selective laser melting or laser powder bed fusion techniques that really can fabricate very strong components But the disadvantage of FDM, in fact, mainly in the anisotropy of the component. So basically, the properties of a component, when you print it, it varies from one direction to another. So there's a huge anisotropy, which is typically is not desired in many components. So that's one of the really disadvantages of FDM. But as I mentioned, this technique is being used now for making metals. There's a company, as I mentioned, in the US, Desktop Metal, which is really co-founded by Professor John Hart from MIT, where they use the same technique using filaments that embedded with metal powder to fabricate the component, and then through a post-processing process, which is using sintering technique, they can really make the metal component with a reduced and a significant reduce in anisotropy. Another question is, as cost-wise, which AM technique is the best to use? That's a very good question. And in fact, this depends on the component. It's not all the components can be fabricated equally with different additive manufacturing techniques. So if you want really the powder bed technique, it's ideal for certain components. FDM is ideal for another components. Stereolithography, for example, jewelry. I mean, for making jewelry. I mean, right now the jewelry industry is significantly using 3D printing, but they don't use FDM or powder bed. Mainly they are using stereolithography based on resin. And the reason for that, because stereolithography gives you very high resolution that is needed by the jewelry industry. SLA, selective stereolithography, in fact, also being used significantly by the dental industry. I would say in terms of the cost, if you want really, and you think that your component can be fabricated with different techniques, in terms of cost, definitely is FDM. If you use deposition modeling, use filaments, the cost of these filaments is really relatively much cheaper as compared to resins or powder. Powder is very expensive these days, and hopefully that the cost of these powders will be reduced with more companies come into manufacturing powder. But I would say definitely if you use deposition modeling is one of the cheapest techniques. And in fact, the printers that you use for FDM are relatively cheap. You can buy a printer literally from China, Korea for about $100. We're talking about 400 dirham as a printer, but the resolution, the capability of these printers are not going to be as compared to bigger printers. So FDM is definitely is a cost-effective technique. The last question I have, which one is faster, the subtractive manufacturing or additive? Well, this is again depends on the component that you want to make, and depends on the complexity of the component that you want. As I said, that there are certain components with very complicated features cannot be really done using CNC machining or subtractive technique. So you need, in this case, additive manufacturing or 3D printing to make this component. So it really depends on the component, depends on the complexity, the use, the functional use of the component. In general, I mean, I would definitely say that if the component is large, then subtractive would be, in this case, faster. So, but there are certain components where 3D printing, especially compact, small components, where additive manufacturing will be also faster. So it really depends on the component, depends on the complexity and the end use of the component. With that, thank you very much for listening to me, and I really appreciate it. Thank you.